Hello, this is AP Calculus AP class with Mrs. Ru. Today we are going to talk about chapter 1.4, continuity and one-sided limit. Okay, continuity and discontinuity. Okay, so there are three different cases for discontinuity. Let's talk about that first. Okay. So number one, when f of c is not defined, so that means there's no function value. Okay? No function value. Number two, it does have the function value, but it does not have the limit value. Okay? So no limit value. So we say that it has the discontinuity. Okay? Number three, it has the function value, it has the limit value, but when they are different, we say that it has the discontinuity. Okay, so when function value is not equal to the limit value, we say that discontinuity. Okay, then what is the definition of continuity? Let's talk about that. Continuity. So when you say the function f of x is continuous, what does that mean? Okay, let's say at x equals c. There are three different cases, conditions, I would say. 1, 2, 3. Okay, continuous, when the function is continuous, that means it does not have this, right? It does not have the discontinuity, right? So number one is that there is a function value. There has to be a function value to be continuous, okay? So f of x, f of c is defined. Number two, the limit of f of x as x approaches c exists, okay? Number three, now what? The function value f of c is equal to the limit value. Okay? F of x, x approaches c. So if the function satisfies these conditions, three conditions, then we say that the function is continuous. Okay, there are two different types of discontinuities. So one is called removable discontinuity. Okay, means you can actually make the graph continuous. Okay, you can make the graph continuous. How? By filling out the hole, okay? Because where the hole is the only place that the graph is disconnected. So in this case, if you look at the graph B, if you fill out the hole, then you can make the graph continuous, right? So in this case, we call it, it has the discontinuity, but it is a removable discontinuity, okay? Another type is called what then? Non-removable discontinuity, okay? Means it doesn't have any hole, okay? It doesn't have any hole. It might have asymptote, or it's just disconnected. Okay, we don't know, but you can't make the graph continuous no matter what. Okay, because it doesn't have any hole. So in this case, the graph A is the case. Okay, the graph A is called non-removable discontinuity because it has the vertical asymptote on the y-axis. Okay. Okay, it says find the limit of f of x equals square root of 4 minus x squared as x approaches negative 2 from the right. Okay, so let's graph this. Okay, what I have is y equals square root of 4 minus x squared, right? So that means if I square both sides, then this is what I have. And x squared plus y squared equals 4. So what I have is a circle, but I only have the positive square root. That means I only have positive y. So the graph looks like a semicircle, okay, that has the radius of 2. And if x approaches negative 2 from the right, then I'm approaching to negative 2 from the right, right? So the answer is 0, right? The notation for this limit is x approaches negative 2 from the right, okay, from the right, because it doesn't have the limit that x approaches from the left. It doesn't have that because it's a semicircle, okay? So limit f of x equals 0 in this case. And this is what we call a one-sided limit because it comes from the one direction, right? So this is when x approaches negative 2 from the right, okay? And if x approaches from the left, then how are we going to write this? Is x approaching negative 2 from the left, okay? So remember the positive sign, the negative sign. Here's another example of a one-sided limit. So it is called the f of x equals the step function of x, okay? So what's the definition? Is the greatest integer n such that, can I erase this? Such that n is less than or equal to x, right? So if I have 3.7, okay, this is the x, and the greatest integer n such that n is less than or equal to x, so that is 3, right? If I have step function of 0.5, then that's 0, okay? So it's asking the integer part of the decimal number, all right? In this case, what would the limit as x approaches from the left, okay? So from the left to 0 is negative 1, okay? What is the one-sided limit x approaches to 0 from the right? From the right. Then from the right to 0 is 0, okay? So if you use the one-sided limit, the same function, but the answer will be different. Okay, let's discuss the continuity of the f of x, that is the square root of 1 minus x squared. Again, it's y equals square root of 1 minus x squared. It's y squared is 1 minus x squared. So I have x squared plus y squared. That is 1. So this is a circle. But again, as I said earlier, I have a positive value of square root. So I have a positive value of y, right? So I only have a semicircle that has a negative 1 and 1, right? So continuity interval will be negative 1 and 1 included, right? So I'm going to write my answer that my function f is continuous on negative 1 and 1, okay? So here's your answer. Let's look at several more examples. So number 1, I have f of x equals x plus sine x. Okay. Then we know that x is continuous for all real numbers. Sine x is continuous for all real numbers. So we add them together. So we say that the answer is it is continuous for all real numbers. So I'm gonna write it's negative infinity to positive infinity. Okay. All right. Number 2, I have f of x equals 3 tangent x. Okay. Then we know that the graph of tangent looks like this, right? And we have a vertical asymptotes, so many of them, right? When in this case it is pi over 2. And here I have the vertical asymptote when it is 3 pi over 2. Okay, so my answer for number 2 is it is continuous except when x is 2 in the bottom, an odd number pi, odd integer pi, right? So 2n plus 1, that's odd, and pi. Okay, and in this case, n is an integer. Okay. Number 3. I have f of x that is x squared plus 1 over cosine x. Okay. Then we know that the numerator, the top is continuous for all real numbers. Cosine is continuous for all real numbers, but since cosine is in the denominator, it can't be 0, right? So if cosine is 0, that means x equals what? X equals, okay, in the unit circle, it is the angle right here and here, right? So that's, again, it's an odd number, pi over 2. So that's 2n plus 1 pi over 2. And again, n is an integer, right? So I'm going to write the answer for this. I'm going to erase a little bit. That the answer for this is it is continuous except x equals 2n plus 1 pi over 2. Here's the Bible verse of the day. So I say to you, ask and it will be given to you. Seek and you will find. Knock and the door will be opened to you. Luke chapter 11 verse 9. Have a great day.
I've searched all over. I couldn't find nobody like you. You're highly exalted, and your name is above all names. That's it. Come on, help me say it. You're an awesome God.